Good morning, children. It is I, Mr. Wizard, Mr. E here, ready to review for the test for you. So let's get right to it. We're going to review on how to solve quadratics. We got 5 methods that we learned this semester, this unit. So let's see which ones we can use here. First off, looks like we're going to start. Oh goodness, I need to. Sorry, it's sprinkling out here, so I'm going to wipe off some of this. But that's okay. All right, let's see. Find the zeros of this quadratic function from the graph. Okay, well, that's easy. I don't even need to look at that. That's what was plotted right here. But the zeros, well, remember, those are the x-intercepts. That's not what I wanted. That is not what I wanted. I wanted this right there. The zeros looks like this one's at 1, 0, and this one's at 3, 0. So there we go. That's what it is. The zeros are 3, 0, and 1, 0. Well, that was easy. On to the next. Let's see, what value for C will make the expression of perfect squared trinomial? Remember, this value here, remember we called it the magic number. The magic number. And all it is this number here, which is B. We take half of it and we square it. So that is, half of that is 6. And the 6 squared is 36. So that's what we put in there before we want to complete the square. Well, this is going really quick, isn't it? All right, let's go. Name the roots of the quadratic shown in the graph. Well, roots are zeros, and they're also solutions, and they're also the x-intercepts. And that's, again, right here and right there. And this one's at, looks like -2, 0. And this one's at 3, 0. So there's that. Let me scooch in. Let's see. -2, 0. And 3, 0. All right. Well, we're just chugging right along, aren't we? All right. Let's see what's next. The area of a square is described by this equation, where x is the length of a side in feet. What is the length of the side of the square? Well, a square, we know that all 4 sides are the same. And you'll see this in geometry next year. We say that they're congruent, which means they're the same size and same shape. So even if you don't know that, look at that right there. All I have is an x squared on this side and then a number on this side. So that means that I can solve this by taking the square root of both sides. I need to unsquare that x, and then I'll unsquare this, and that becomes, well, let's see. I can plug that into a calculator and see if it's a perfect square. Let's see, the square root of, no, clear. Let's see, my calculator says the square root of 441. Oh, it's 21. So x equals 21. So that's the length of the side of the square. 21 times 21, here's a square. If this side is 21 and this side is 21, you multiply them together and you get the area. And that's what we have. All right. Let's see. Oh, here's an actual one we need to solve. Let's go. What are the solutions to this? Well, let's see. I'm going to first, let's try to factor it. Let's see if it's factorable. Let's see. Make a little x here, and we got a, c on the top and b on the bottom. Let's see, a, b, c. So let's see. A times c is 12, and b is 7. So let's see. 2 numbers that multiply together to get 12 and add together to get 7. Well, that's 3 and 4. So that works. So I'm going to draw my box, and I'm going to plug in these numbers. That first term, that doesn't change, and the last term doesn't change. But we split the middle into this plus 3x and a plus 4x. So now I can take the GCF of each row and column. Let's see, 2 and 3 don't have anything in column, and those numbers don't, but they each have an x. And of course, an x goes up there, just like always. Let's see, 2 and 4, that has a 2 in common. And then 2 times 2 gives me 4. 2x times 2 gives me 4x. And then 2 times a positive 3 gives me 6. So there's my factors. 2x plus 3 times x plus 2 equals 0. Now I've changed this from standard form into factored form. And then all I have to do is solve for x for both of these. So I'll subtract 3 from this side, and that gives me 2x equals a negative 3. Divide by 2. X is minus 3 halves, and then this one over here I just need to subtract 2, and x equals a minus 2. So my solution is this. Minus 3 halves, comma 0, and minus 2, comma 0. There we go. Okay, so we've done one with factoring, and we've also done one with taking the square root of both sides, and we've done one by looking at the graph. So, let's see. Multiple choice. This will be easy. Let's see. Which of the following is proper use of the quadratic equation to solve this? Okay, so the quadratic equation. Well, we're just going to plug it in, aren't we? We're going to be, let's see, it's going to be x equals minus b plus or minus the square root. That's ugly. Square root of minus b. I can't believe I don't know this by heart because I'm refusing to learn that song. Quadratic Formula. Yes. Oh, yes, b squared. I knew that. Minus 4 AC. There we go. Hey, give me a break. It's like early Sunday morning and I'm doing this, so you wouldn't want to remember the quadratic formula if you didn't have to. All that's over 2a. So let's plug in a, b, and c. So this is going to be x equals negative b. Oh, and that's a negative 6 plus or minus the square root of b squared, and that's minus 6 squared minus 4 times 5 times a negative 1. All right, all that's over 2 times 2 times 5, 2 times a. This is ugly. 2 times 5. Okay. I'm running out of room, but that's okay. I can move this in a minute. Let's see. Okay, so let's simplify this. X equals minus 6. That's a positive 6. Plus, let's see, do they all have positive 6? Oh, this one does not. So we can eliminate A. That one's not correct. 1 down, 3 to go. Let's see. 6 plus or minus the square root of, let's see, minus 6 squared is 36. Minus 4 times 5 is a minus 20. And then a minus 20 times a minus 1 is a plus 20. All that over 2 times 5, which is 10. And then we can simplify this to 56 over 10. So let's see. This is over 2, so it's not the D. And this one has 16 as a discriminant, but it's not 16. It's 56. So this answer choice is C. All right. I'll move it. That's not what I want. I'll move this out of the way so we can keep that. Let me shrink. There we go. Okay. Oh. Whoops, that's not what I want. Let me get the pencil back. All right. There we go. Okay, let's see. Next, which of the following represents a root of this quadratic equation? So root is just a 0, just a solution, just an x-intercept. But notice there's no b term here. There's no bx in this, which means I might be able to solve by taking the square root. So let me see what I can do here. I'm going to add 6 to both sides. That'll give you minus 3x squared equals, let's see, that's a minus 6. And then I'll divide by a minus 3. So that gives me x equals positive 2. I don't need to write the positive. x squared. I'm sorry, x squared. It gives me a positive 2. So yeah, there we go. Let's take the square root of both sides. X equals the square root of 2. So let's see. I'm going to plug that in my calculator and see the square root of 2. I'll clear this out. The square root of 2 is 1.41. So it's this right there. There we go. There's a root. All right, let's look at the next ones here. State the number of solutions for each of the following. Remember, we use the discriminant, which is the piece under the radical there, and there, to see how many roots there are, how many solutions. And if it's positive, a positive discriminant, that means we have 2 real solutions. A negative discriminant right here, negative discriminant. I'll abbreviate that. Negative discriminant means no real solutions. And then here's the other one. A 0 discriminant means that it's just sitting on the x-axis there, so you have 1 real solution. And let's see, I will do one of these for you, these next ones. Why don't I do that one in the middle? Because I know you're going to, if I was in class, they'd say, well, do that when it has the most terms. So let's do that one. Let's see. That might be factorable. Let's see. A times C is 1, and then 2 on the bottom. What are 2 factors of 1 that add up to 2? Well, 1 times 1. So let's do that. X squared here, and a 1 there, and we split it into x and x. So x here, x there, plus 1, plus 1. Well, that was real easy. Of course, you could see that was a pattern that you might recognize. But let's rewrite it like this. X plus 1 squared, because these are both the same, equals 0. So that means I can take the square root of both sides. X plus 1 equals 0. The square root of that, the square root of that. So subtract 1. X equals a negative 1. So that one has one solution. It's negative 1. So 1 solution. And I'll leave the other 2 for you, and I'll give you a hint. It's easy. You don't have to use quadratic formula. It's one of the easier methods. Okay, let's see. Let me move my work out of the way real quick. Just make this a little bit smaller. Okay. Let's look at this last bit here. Let me get a different color. Oh. All right, name the zeros to the following quadratic equation. Remember, zeros are the x-intercepts, and that is where y equals 0. So here's a 0. So minus 1, 0 is one of them, and right here, 3, 0. There's our zeros. Is that first page? All right. Wow, we're just chugging right along. Let's look at the next page. And this is the last page, isn't it? It sure is. Wow. Okay, well, I'm going to choose a couple here to do for you. And you know what? I'm going to do the first 3. And we'll use a different method for each. Well, look at this. No bx. Whoops. No bx term. So I'm just going to solve by taking the square root, which means I'm going to add 81 to both sides. And you might recognize that 81 is a perfect square, so that's going to help us. Let's see, that gives us 25x squared equals 81. Oh, whoops, I left the 5 off. So 25x squared equals 81, and then divide. Why does it do that? Divide by 25. So now I've got x squared equals 81 25ths. Now, don't despair. We've got this fraction. It looks a little ugly, but 81 is a perfect square, and 25 are perfect squares. Both of those are perfect squares. So I'll take the square root of both sides. So x equals square root of 81 is 9. Square root of 25 is 5. So there we go. Those are my roots. 9 fifths, comma 0. That's my roots. Let's see this next one. Well, that's awfully ugly. So you know what I'm going to do? I'm going to open up desmos.com and go to the graphing calculator. And I'm going to just plug this in and look for it. Let's see, 3x squared minus 7x minus 6. 3x squared. Oh, I'm going to have to open up a keyboard. 3x squared minus, what was it? Minus 7x minus 6. Minus 7x minus 6. Oh, there we go. Let's see. The solutions are, what happened? Right there and right there. 30 and minus is 0.6670. So let's plug those in. Those are my answers, and I solved by graphing calculator. That's the easiest way. 30 and what was it? Minus 0.667, comma 0. There we go. Oh, we need to put them down here in the answer slot or in the answer area. So here we go. Zeros. Alrighty. Let's do this next one. Is that going to be factorable? Let's see. A times C is 10. And let me get my pen back. A times C is 10. Are there two? Let's find out. A times C is 10, and this is a negative 7. I'll make this bigger. 10 and a negative 7 on the bottom. Two factors. Well, it's 2 and 5, but can I, let's see, minus and a minus? Yeah, that works. Okay, that is factorable. All right. So let's see. This is going to be x squared, and this is going to be a plus 10. Then we split the middle to be minus 2x and minus 5x. So I know an x goes here and an x goes there. And then really all I need is, well, this is going to be minus 2 and a minus 5, isn't it? Because a minus 2 times minus 5 is a positive 10. Minus 2 times x is a minus 2x. And then x times minus 5x. There we go. So we've got x minus 2 and x minus 5 equals 0. So x minus 2 equals 0. And we just add 2. So x equals a positive 2. And the same thing, you probably figured out the shortcut by now. If there's no a value, then just take the opposite sign of this. X equals a positive 5. So the x-intercepts are 2, 0, and 5, 0. All right. Let's see. I need to cover myself real quick because it's starting to rain. So I'm going to get under my blanket when I do these last bits here. All right. Oh, I said I'd only do 3, but I'll be nice. I'm going to do one by... Can I do one by completing the square? Yeah, let's do... I'm not even going to... Since completing the square always works, I'm going to do number 15. If it'll let me change my color here. Hello. Something's wrong with my pen now. Just a second. Let me get the water off here. There we go. Okay, let's choose a different color. Okay, let's complete the square with this. 2 factors of 6 that add up to 6. That actually doesn't work, does it? So we will have to complete the square. Let's see, 2 factors of 6 that add up to a negative 6. Well, the factors of 6 are 1 and 6. Even if they're negative, that doesn't work because that becomes minus 7. Excuse me. And the other factors are 2 and 3. Those add up to be 5, so we can't, we're going to have to complete the square. So let's do that. So I write down both b over 2, which is minus 3, and b over 2 squared, which is the magic number. So that's going to be a 9. Because we're going to use both of those. First off, we're going to move this 6 over. So I've got, let me get some room here. I'm going to move these guys over here. All right. So this gives us x squared minus 6x equals a minus 6. And I'm going to use a magic number here, plus 9 plus 9. So now we've got a perfect square trinomial, and I use this number to factor it. That's all there is to it. Minus 6 plus 9, that is a positive 3. So now all I have to do is take the square root of both sides. Square root. And that just cancels that. So I've got x plus 3 equals the square root of 3 plus or minus the square root of 3. So subtract 3 from both sides. And my answer now becomes x equals minus 3 plus or minus the square root of 3. So that's what I'm going to write for my answer. Minus 3 plus or minus the square root of 3, comma, 0. Those are my zeros. Remember, there's 1 for positive and 1 for plus. 1 for plus, 1 for minus. All right. The rest I'm going to leave to you. I've done 4 out of 9, so almost half. And you can probably see which ones, like this one right here, number 13, there's no b value, is there? No bx term. So I've done a couple of those. This one right here, well, it's got an a value. So if you wanted to complete the square, that would be, you would need to have an a value of 1, and that will give you some fractions. So you know what? Plug all the rest of these into your calculator. Oh, look, this one doesn't have a bx term either. So there's some hints for you. Remember, the ways that always work, completing the square and the quadratic formula, those always work. If you don't want to do either one of those, then, well, here, no, go this way. Graph them first. Plug them into your calculator. Look at the graph. Plug them into Desmos. Look at the graph. Take the solutions off of there. If it's a fraction or something, if you've just got your calculator during the test and it's a fraction, you can't really figure the table out, complete the square or plug it into the quadratic formula, and that'll work. You can try factoring, but remember, if it doesn't factor, you'll have to use a method. And unfactorable does not mean that it's unsolvable, because they're always solvable. So there you go. There's the review. I left 5 problems for you with some hints. And good luck. I'll see you next time.